Hi all. As we know that except noble gases, no other element can exist as independent atoms. Here the group number 18, these elements are called as noble gases. Helium, neon, argon and other elements, these are the noble gases. These elements can exist as independent atoms. Whereas other elements starting from group number 1, 2 up to the group number 17 here cannot exist as independent atoms. Why it is so? It's just because that these elements are not having the stable electronic configuration, so that's why they are present in the form of different types of compounds. While as noble gases, they can exist as independent atoms just because they have the stable electronic configuration, right? They have the stable electronic configuration. So in different types of compounds, the two different atoms are held together by a force of attraction, which is called as a chemical bond. So a chemical bond is a force of attraction which holds the two atoms together in a molecule. Like suppose we can take an example of a hydrogen molecule. In the hydrogen molecule, the two hydrogen atoms are held together by a force of attraction. So there is a force of attraction which holds the two atoms together, and that's what we call as a chemical bond. Similarly, we can take an example of a sodium chloride. In a sodium chloride, which is an ionic compound, here the force of attraction is between the sodium ion and the chloride ion, between a cation and the anion. So again there is a force of attraction. So a force of attraction which holds the two atoms together, that is called as a chemical bond. Now the question is how this force of attraction develops. So there are different ways of different ways by which this force of attraction between the two atoms develop. And accordingly, we have different types of chemical bonds. Suppose if you look at the NaCl, sodium chloride, here in the sodium chloride, we find that there is an electron transfer from sodium to the chlorine. Sodium with the atomic number 11 has electronic configuration of 1s2, 2s2 and 2p6, 3s1. In our lower classes, we also know that we can write down the electronic configuration of the sodium here like this: 2, 8 and 1, 2 in the first shell, 8 electrons in the second shell, and the last shell has a 1 electron here. So sodium can gain the electronic configuration to this nearest noble gas. Here this is the position of a sodium, and this nearest noble gas is neon. So when sodium, it loses one of the electron, valence electron, after that it gets a positive charge, and now sodium ion has an electronic configuration of 2 and 8, which is similar to the electronic configuration of the neon. So sodium ion has an electronic configuration of the neon when it loses the electron, right? So that means sodium atom can gain the electronic configuration by the loss of electron here. And chlorine, its next element with the atomic number 17, has electronic configuration of 1s2, 2s2, 2p6, 3s2, 3p5, right? So, or you can also write it like this: 2 electrons in the first shell, 8 electrons in the second shell, and 7 electrons in the valence shell. So chlorine needs 1 electron so as to have a 8 electrons in the valence shell. That means after the chlorine, here is the position of chlorine, after it gains 1 electron, it will have electronic configuration similar to the argon. Alright, so that is why chlorine, it will accept electron, and therefore it has now 8 electrons in the valence shell. Now its electronic configuration will be 2, 8 and 8, which is similar to the argon, a noble gas. That means after the loss and the gain of electron, when the sodium and the chlorine react, there is a transfer of electron from sodium to the chlorine. So now sodium becomes Na positive and chlorine is Cl negative. These are the oppositely charged ions, and there is a force of attraction between the cation and the anion, and the force of attraction that holds these ions together is what we call as an ionic bond. So ionic bond is a force of attraction. Similarly, we can take an example of a hydrogen molecule, right? in the hydrogen molecule, it has a 1 electron there in the valence shell, another hydrogen atom, it has a 1 electron, so they can share this electron pair. Now this electron pair, it is being shared by the two atoms, it belongs to this hydrogen atom, and this electron pair again belongs to this one. And again, by the sharing of electrons, there's a force of attraction between the two atoms. So the force of attraction that develops by the sharing of electrons is what we call as a covalent bond. And again, this covalent bond is what? It's the force of attraction, right? So this is the force of attraction. We will discuss about the different types of bonds in our coming videos.